All right, let's get back into patterns. To remind you all where we left off from last week, we've got a basic filtered triangle wave synth-def here, so we can play it, and we can set its gate to 0. We've got this gated attack, sustain, release envelope. We introduced the concept of events, and the event just being an unordered namespace style collection. So, sort of just a very simple idea. Events respond to the play message by making sound. And so we saw that we could provide a bunch of parameters, frequency, amplitude, or variations on those parameters. MIDI note, degree, dB instead of amp. And then we also introduced the concept of some simple value patterns. And these value patterns are just little, pre-existing algorithms that generate data according to some specific way, some algorithms. So pseq is just a sequential pattern. We can convert it to a stream and call next, and then we just get this infinite stream of 60, 67, 74. And then we also introduced Pbind, which is a pattern which defines a sequence of events by binding outputs from value patterns with keys. And so this is an example, a very simple example where we have a Pbind called P. We convert it to a stream, and if we pass it an empty event when calling next, what we get is an event where each key in the event has been assigned the next value from its corresponding pattern, or in the case of the instrument, just a single symbol. So the instrument is always going to be try. MIDI note is going to be 60, followed by 67, followed by 74. And P white is a random number generator between a low and a high, and so we just get a random value with a sort of uniform distribution each time. So we can call play on each of these events that comes out. But then we can also play a Pbind and capture the results in another variable. So what's returned from p.play is something called an event stream player. And it'll just play forever. We can stop it whenever we like. And that's kind of the basic framework on which we're going to build today. And we were also kind of unpacking some of these various pitch parameters. So we see that degree in the default event structure is 0, and then note is calculated from degree and a bunch of other keys, and upwards to MIDI note and frequency. And on the amplitude side, we have a default decibel value of -20, and amp is just calculated from that value converted to amplitude. So I actually wrote down some of the things I wanted to cover today. I don't think we'll get to all of them, but we'll get to as many as we can. Where we left off at the end of class last week was the observation that when we play this Pbind, the notes have a certain length, and the time between onsets of successive notes also has some value. And we were sort of wondering about where those values come from. And so that's the topic of this first item here. In addition to keys like freq and amp and all those other ones that are built into the event structure, there are also some keys like sustain, dur, and legato. And so let's start by talking about sustain. And let's grab this example from up here and paste it in here. And so we observe that when just creating a synth that has a gated envelope, we have to manually set the gate to 0 at some point in the future, otherwise it just plays forever. Now if we create an event using that same synth-def and play it, it stops by itself. And this is really convenient. And that is because in the note event, which is what we're generating by default, there is there's a key called send gate, which is true by default. And we can set this to false, and then it behaves like a normal synth. So we have to hit command period here. When we generate a note event, under default conditions, so send gate is true, a corresponding gate 0 set message will automatically be generated, and it will be sent sustained number of beats after the note event is first created. So let's look at the sustain key, and we can say 1. So this, I think this just this is technically beats, but if we just play an event, I think beats are just seconds. We're using the default. We're not even using a clock here. We're just playing an event. So and we can set this to 0.2, and then a fifth of a second later we get the gate message. So this is the sustain key, and this is basically what we one option to specify the overall length of the synth created as part of that note event. And of course, sustain is also subject to pattern control, so you can use prand, pwhite, whatever to modify that sustain time, just like you can with freq and amp and all of those. And let's actually take a look under the hood at the sustain function. And it is the product of a key called dur, a key called legato, and another one called stretch. And so dur by default is 1. Stretch by default is also 1. And legato is by default 0.8. So what this means is, actually, I think there's if we go to the Pbind help file and search for sustain, yeah, so we can, that's not it. Maybe it wasn't in legato, perhaps. Yeah, so legato is defined as the ratio of the synth's duration to the event's duration. And you can think of this musically pretty easily. If legato is 1, it means that each note is sort of, assuming dur and stretch are 1 as well, the length of the synth will be exactly the length of the event. And so we connect the notes, and you can imagine them kind of being slurred together. You can't even make legato greater than 1, in which case each note will kind of bleed over into the onset of the next one. And if legato is between 0 and 1, then we have more clear articulations, and with a legato value very close to 0, we get staccato. So it's a nice sort of musically intuitive way of dealing with this. So let's let's just copy this Pbind. Why not? And we will add. We can just sort of. We can just like directly control sustain itself instead of relying on the product of dur, legato, and stretch. This is fine, but maybe not this is what I do in the book, and sort of in retrospect, maybe I should have been focusing more on legato instead of sustain. But either way gets the job done. So we can do pseq 1 and 0.1 forever. So you get the idea, right? Let's do so legato, same sort of idea. We'll do pwhite here. Yeah, so some short, some long. And then there's the question of what is controlling the actual timing between the onsets of successive events, and that is dur. Dur is doing that. So this is dur is kind of the primary option for just rhythmic specification. The default value for dur, as we already seen, is 1, and this means 1 beat. And then the question is, okay, what is the tempo? And if we don't specify a clock when we play a Pbind, it's going to fall back on the default tempo clock, just like routines. So in that case, dur is seconds, because 1 beat at 60 beats per minute is 1 second long. So we can specify a quarter here, and let's do pexp rand and make these some nice short staccato notes. So those are 1/4 of a second long. Here's 1/2. And the process of playing on a clock is exactly the same as routines. We're just going to give ourselves tempo clock. Let's do 175 beats per minute. And we just provide the clock as the first argument for the pattern. So this will play. These are 1 beat at 175 beats per minute. And there's 175. So I think probably if you're interested in controlling the timing between successive onsets and also the length of the actual synth relative to the timing of the events themselves, Dur and Legato is a good combination to use. This is pretty good. And stretch. Stretch has the effect of scaling the entire timing apparatus. So it will scale the sustain value as well as the durations. If we so let's see what that sounds like. So stretch value of 1, and if we stretch this out by a factor of 1.5, and let's go out by a factor of 10. So I just did this to show that the notes are much longer. So it's also scaling sustain as well as the timing. So stretch is kind of a good way to modify the base tempo, but also keeping the note proportions as they are. And since we're talking about clocks, let's briefly talk about quantization as well. So let's get rid of that, and let's do a p. Well, sure, okay. Do 1/2, 1/4, 1/4 forever. And the order of arguments for patterns is the clock and then something called proto-event, which is it's basically a sort of initial event passed to the pattern. So you might want to pre-fill the event with other things and then have the Pbind fill in the rest. I rarely use this, but I mean it's useful in some cases. So we're going to skip over that and just specify quant. And this is just like with routines. So if you specify an integer, it's going to just be the granularity. You can specify an array for granularity and then timing offset. If this is unfamiliar, you can go back and watch the lecture video from that week. So we'll say quant4 and just make sure our clock is still running, and it is. So I'm gonna prepare another one of these here, and all I'll do is a chromatic transposition up by 3. So just so it's a different pattern, and I really shouldn't be using single character letters, but we're going to do it anyway because I'm a irresponsible coder. All right, so we're going to play this one, and it will get quantized on the next beat multiple of 4 on clock t. And then I will play this one, and it comes right in with that one, and so that's quantization and clocks. Very handy. And with Dur, Legato, possibly sustain, clocks, and quantization, you have pretty much everything you need to specify any kind of rhythmic information with precision. I'm pretty sure I mentioned the rest event when we first started talking about events, right? We have the note event, which is the default, and the rest event, which is identical except for the fact that it makes no sound. So it can't have a duration, all that sort of stuff. That's really the only thing it has. It's just a Dur value. So obviously we can do type note, play that, we make a sound, and if it's a rest, we don't. So I want to go just talk about how we can specify rests in the context of Pbind, and just to kind of reinforce why they're useful. If, for example, you are specifying some highly complex but metric sequence of duration values, like dotted eighths and whatnot, or something like that, it can be a little bit clunky, or it can feel a little clunky to have to specify all of those values kind of specifically. And it's hard to kind of read musically, just because you're specifying the number of events in that sequence rather than the way notated music is written out with notes and rests and things which kind of make it a little bit more easier to intuit. So one option is to let me just come up with a kind of a very, very simple example here. Let's just say we want I tell you, I'm just going to go for it here. So we're just going to make the duration 16th notes. Just every event is a 16th note. And so let's forget about the clock and the quantization just for simplicity. So we'll play this back on the default tempo clock. And each event is going to be a 16th of a second long. That's a little fast. Let's do 8th notes. Let's add a few more notes. So what we can do is one option is for the type. We can do a P-seek, and we could say we'll do note, note, rest, note, rest, note, note, note. Let's say we're imagining a 1, 2, 3, 4, 5, 6 those notes in this 8 cycle. And so what we might do is just dump some bogus, just some it doesn't matter what these values are, right? For if we come across an event and it's a rest type event, it does not matter what the MIDI note is. It does not matter what the decibel value is. So you can kind of just write in some values to kind of visually show that these are the rests. And so then we have this, and I messed something up. We need a comma here and an inf here. So that's an option. You can also build this into the duration key itself. So we'll just fall back on the default event type, which is note, and in the P-seek, we are going to say 1/8, and then rest. We're going to use the rest object. Right? So there's actually an object called rest, and we just provide the duration. I often like to use the return, to kind of show, if you want to sort of space it out as a grid, it's kind of nicer than just writing out everything all in one long line. And you can hold Shift and press Tab if you want to be extra meticulous about alignment, if you're interested in that sort of thing. It's really just for readability. So that works fine. And then there's one last, so this is kind of the recommended way to do it, is by using the rest object. Here's another variation on rests. Just kind of showing you different styles here. We can just put the duration back to where it was and put the rest objects in any stream. We don't have to put duration here because that's handled by, the duration is always going to be 1/8. And so if any value pattern spits out a rest, the corresponding event type becomes a rest type event. So this will also work. So you can put the rest wherever you think it makes most sense, and maybe it makes sense in the note or the frequency pattern because you have notes and rests. And there's one last cute trick, which may technically be deprecated and won't work in all cases, but in my experience is that it always still works fine. And you can just put any symbol in any of the pitch key patterns. So freak, MIDI note, note, or degree. This is the empty symbol, but you can put an R for rest or whatever you want. Any symbol will cause the resulting event to become a note type event. So I like these two approaches. I like putting the rests in the note pattern. That feels musically intuitive to me. And it's really important to use rests. The wrong thing to do is build zeros into your amplitude pattern, because that still generates note events, so it still consumes processing power. You're just going to be just writing a bunch of zeros, to the server's going to be just producing a silent synth, and that's inefficient. And I think also a little kind of clunky. So take advantage of rest events. If you're thinking of some rhythmic pattern which is notes and rests, then use rest. I mean, just imagine if in notated music we always had to write notes on every beat, but we had to specify a dynamic of niente to indicate that. That's kind of the equivalent of not using rests. So use them. It makes for more readable code and more intuitive musical thinking. OK, this pattern will play forever. We can let it run, and off it goes. It'll never stop until we actually tell it to stop or hit command period. So then the question is, what is it that causes this event stream player that is returned from playing the Pbind to be infinite? And the answer is that all of the internal value patterns are either a single piece of data, like a symbol or a number or something, or they are value patterns which themselves are infinite. The length of the resulting event stream player will be equal to the length of the shortest value pattern inside of it. So we can say, let's just make only 8 events. And we only get 8. Right? That includes notes and rests. Those are both events. We can do 12. We get 12 there. This works fine, but it can be a little awkward. If you come back to your code and you're like, oh, I want this to be longer, and then you have to hunt through your patterns. And which is the one that I made finite? Because from the Pbind's perspective, it doesn't matter. It just runs out of values at some point and says, OK, that's the end of the event stream. So I think a better option for making your Pbinds finite is to just make the Pbind infinite. Just think infinitely for everything. And then wrap the Pbind in a pfin, which takes a count and a pattern. And the count is the number of events to generate. So we can do it this. I mean, if you like to do a step-by-step, this is fine. You can also just kind of do it this way. Sort of actually wrap the Pbind inside of a pfin. And the pfin is just a constraint pattern, which is going to say the event generating pattern inside of me, I'm going to tell it to stop when it reaches 12 events. And so I like this approach rather than actually kind of having to micromanage the internal patterns and deal with those. But and if you have multiple finite patterns, whichever one is shortest is going to determine the length of the event stream. Just like if you have 2 done action 2s in a synth step, whichever one gets there first is going to determine the overall length of the synth. And on the topic of pfin, there's also pfin dur. So it's the same idea. We're constraining the length of the pattern, but it's not going to base that on number of events. It's going to base that on a duration in beats, which of course is determined by the clock on which this is playing. So we'll say, I just want this to last for 4 beats, and we're playing it on the default clock, so this will be 4 seconds. 2, 3, 4. Yeah, that's all we get. Right? So sometimes you want to think in terms of time, and sometimes you want to think in terms of number of events. This is especially useful if you want this event stream player to last a certain number of beats, but the duration values are completely random or something, where it makes no sense to count events in that point because you have no idea how long each one of them is going to be. So that's basically it. I see all these have automatic playback copied along with them, which I'll clean that up later. Any questions so far? All pretty straightforward stuff. Good. Okay. So now let's sort of put on our composer hats a little bit and recognize that having a bunch of Pbinds everywhere is workable, but it's sort of like it's not particularly reusable or combinable. I mean, so you sometimes want to kind of think in terms of. Oh yes, question. Go ahead.
And I'm so sorry. My question was that will the event stream, because we've seen that like pseq or whatever, when it runs out of things, it returns nil. Does the event stream basically just as soon as it gets nil on anything, it stops itself?
That's
look for nil specifically?
I was actually thinking about this the other day. Yeah, and I think let's find out. I think if any of the keys in an event generated by playing a Pbind is nil, I think that's its cue to stop. But let's find out. So let's take this one, and so let's do this, right? So we should hear 3 notes, and everything else is infinite. So let's see if that works. Yeah.
Okay.
So if you just put a nil into one of your patterns, like a p-seq or something, that will prematurely terminate the event stream. So it's quite simply checking for nil, I guess. Yeah, as far as I can tell. That is interesting. All right. In some types of projects, it makes sense to build small finite Pbinds that represent a particular phrase, maybe a deterministic one, maybe a random one, and then other Pbinds, which are other phrases, maybe different lengths, different styles, different synth defs, whatever, and then build these composite event streams using a variety of list patterns, so that you can kind of build larger phrases and then define those as their own sort of event pattern, and then build even larger. Let me show you what I mean. Let's take this simple Pbind here, and we're not gonna play it yet. We're just gonna call this environment variable p0, and it's going to be exactly 1 beat long. And let's make another one, which is up by 3 semitones. And this is a little, there's a way to sort of create a template pattern, and then have p1 be based off of p0 and only have this inside the pattern. Maybe we'll get to that if I remember, if anyone's curious. But I'm just trying to do things quickly here. And I'll make one more, which is shorter notes up 7 semitones, and let's make this one have longer sustain values. Okay, so three patterns. All right. So we have three little phrases. And all we've done here is just define the patterns. Right? We have not dealt with the event stream players yet. But we can then create, say, phrase 0. This is going to be a p-seq, which plays p0, followed by p2, followed by a p-seq that plays p1 twice. Right? And we'll make another phrase, which is I'll introduce p-par here. So this p-seq is sequential. It's going to go through one at a time. P-par is going to take an array of multiple event patterns and basically merge them into a single event pattern. It's roughly the same thing as just playing 2 Pbinds at the same time, but this allows us to refer to it as a single pattern, which then allows us to reuse it and make variations on it and stuff like that. So we'll do we'll play p0 and p1 3 times. Right? That'll be our other phrase. So let's just see what those sound like. Right? Right? Just going through sequentially. We don't really need to do this 3 times. We could just as easily say, OK, just play phrase 1 3 times. Run that, and this. Same idea. And then you could then take this a step further and build larger level phrases or sections or something like that from your phrases. And let me go into, let's see if I can find the examples. Ooh, I might be in the wrong place. Yeah, I don't think unless I. Yeah, when you I might just not have installed this, but when you download SuperCollider, there is like a sort of parent folder in which the application executable file lives, and there's you can hunt down a folder of example code, and in the examples folder there's a folder called pieces, And one of those pieces is a recreation of the song Space Lab by Kraftwerk. And that is one of the best examples I've seen of using patterns in this modular way, because it's a that piece of music is very sectional, and the sections are all very well defined, and they kind of repeat, and then they happen together, and so someone I'm not actually sure. I think it's like signed by just someone's initials, so I'm actually not sure who wrote it off the top of my head. But if you want to hunt that down and just take a look at it, it's a really good example, because all of the synthefs are very simple, all of the Pbinds are very simple, and then at the bottom there's just a P-seq that kind of just defines what is essentially the score, which patterns to play in which order and how many times. So depending on, if you're working on a certain type of music, which is very, repetitive and structure-based and, modular in that sense, this is a really good way to do it. So that's modular thinking with patterns. It's think about your, moving on. Let me grab my sort of running template here, and let's redefine some things here. And so, if we just do MIDI note 60, we get 60 every time, 64, right? What do you suppose happens if we return an array of two values? So the value that gets plugged in to the event at the key MIDI note is the array, 60, 64. What do you think? You can probably guess here, right? Two synths, right. It's not showing them. We'll make the legato a little bit longer. Yeah. Well, they're actually appearing and disappearing, each time anyone is. But yeah, so we can build chords in this way. And and this is where pfunc can be kind of useful, where we just evaluate a function that returns some value, and that'll get plugged in every time. So we can just say, let's randomly, linearly, randomly pick notes between 40 and 80, and I would like 4 of them. And we'll round these to the nearest multiple of 5. Pfunc is really, really handy. I've a couple times in the past, students have said, I just don't understand pfunc. It's like, because it's like too open-ended or something. But it really, all it is you provide a function, right? Here it is. And when it is time for the Pbind to say, OK, I need the next value for MIDI note, it just evaluates the contents of the function. And that is what gets plugged in for MIDI note, MIDI note, MIDI note, MIDI note, MIDI note, right? We can even say, I want this to be sometimes 1, sometimes 5, right? Or anywhere in between. So the actual duplication can also be subject to randomness. So and this idea of providing an array of values for a key works for most of the keys. It will not work for duration. I think, and I think this is just a sort of design consequence, is that when you play a Pbind, it can't sort of split itself off into several differently timed event streams. It would be nice if it automatically kind of became a P-par, but I think there's probably, if you dive down the rabbit hole and kind of figure out what would need to change, it's complicated to kind of deal with the temporal aspect in this sort of array-based idea. There's probably a better explanation than that, but I'm pretty sure if you try to provide an array of 2 values, something funky happens. It just doesn't like it. Something fails. So if you want 2 different event streams with different timings, I think you just kind of have to define them independently. All right. So, but it works for, I think, decibels as well. If you want 2 different synths with different levels. Yeah. So keep that in mind. This is a really handy feature. Yeah.
Does calling an array of instruments work?
I think so. Let's see if we can figure out if it works. Let's let's make that 60, and well, I'll copy this, and what I'll do is very quickly take. You know what? We'll just copy that and say noise, and let's make sure that makes sound. Yeah, okay. So that's good. And then I wanted to go back, and I do this all the time. I put like a little marker for myself and scroll away, and then I do a find to come back to it. It's my little. I'm sure I'm not the first person to think of that. But probably other fancy IDEs have like better tools for that, like collapsing parts of your blah blah blah. Okay, and then so we want to know if this works. Seems not to.
Okay. So would it then be correct to say that we can pass arrays on events that, or sorry, on keys that would go into the synth, but not keys that go into the event?
I think that's right.
Okay.
Maybe not right across the entire board, but I think as a general rule of thumb, if it's a key which is associated with the event structure, then it probably doesn't expand in that way. So it might also not work for Legato. But if it's something which is getting plugged into the synth-def, or even propagating upwards from from MIDI note to freak or something, then it does work. I mean, always worth a try. And then something else I wanted to talk about here is let's make an array of. Oh, you know what? I'll just do it this way. 5 starting at 60 and going up by 7. So same thing here. Just always doing those 5 notes because this expression returns this array. We'll make this a little longer, and we'll do a nice full. We'll just use the default 0.8. There's another key which is built into the event hierarchy, which is strum. And this is a duration in beats by which to separate the simultaneous events, like strumming the strings of a guitar. I think it's seconds, yeah. Well, we're on the default tempo clock, so you'd have to play this on a different clock to confirm whether this is. I think it's beats, yeah. And then you can get like kind of interesting delay effects by making the strum unusually long. Let's do 0.75, and let's also do starting at -20 and going. Nope, sorry. 5 of these starting at -20 and going down by 4 decibels each time. Maybe not the most interesting example, but so what does this do? Ends up in like a reverse strum because they almost sync up with each other. Yeah. So, and interestingly, yeah, they all get the way strum works is that these events get scheduled in advance on the clock. So stopping the event stream player does not unschedule those events, which is why, so just another quirk of, but yeah, using arrays for synth-def values and then strumming them will space the synths out. It's kind of handy. Yes?
Does strum take negative values as well?
Ooh, I don't know. That's a great question. Does strum take negative values? Let's find out. It does, right? Yeah, cool. I did not know that. Now I do.
What about an array of values? Like say you wanted
Ooh.
to delay individual strums?
Something like this?
Yeah.
Doesn't like that. I guess it sort of doesn't make sense in some way. Yeah. Welcome to the world of experimental patterns. You get this in the post window a lot. It's like, oh, okay, sorry, I'll show myself out. I was never here, right? But good question. No. You can definitely subject this to pattern control. Something like this, I think. And I think this just means every time one of these events that results in 5 synths is played, the strum is randomly chosen. So not quite what you were after, but I guess better than a static strum. Yeah. OK. What do I have here? Pitch specification for an instrument. OK, yeah. This is going to be, I actually prepared this in advance. So let's say you're working with a synth-def that plays a buffer instead of synthesis. Now, with synthesis, pitch specification is trivial, right? You just declare a freak argument, and you get access to MIDI note and degree, and your life is good. But when you're using a sample, it's nice to be able to specify freak and MIDI note and whatever and get the same behavior, because we want to transpose the playback rate in a way which is musically intuitive. So here's a little glitchy file, just a little sample that it came from somewhere, I don't know. And its frequency is something. That was close. OK, that's right. Yeah. So 1580 hertz. And so we would build a synth-def that kind of looks like this, where we have a play buff, always using our buff rate scale just in case of rate mismatches. And then we have an argument called rate. And this is the playback ratio, so 2 is an octave up. You would know this already. So very simple synth-def. And we can do MIDI ratio to do semitones. Right. And so we can play this with an event by saying use synth-def B. And we can specify the rate as MIDI ratio. But we can't do anything like this. Right? This doesn't work. MIDI note, degree, they won't work. So we have to modify the synth-def in order to, what we want to do is redefine the synth-def so that it includes a freak argument, which will result in the appropriate rate value. And this is easier than you might think it is. What we need to do is just take the frequency, we want to provide a frequency value, and then just divide it by the base frequency of the sample. So this sample normally plays at 1580 hertz, and so if we provide a frequency of 1580, what we get here is 1, which is normal. And if we were to provide, half this value, 790, then freak would be 0.5, and the frequency would go down by an octave. So now, if we say freak 1580, now we get kind of intuitive frequency control, which means because we've gone with we've aligned ourselves with the structure of the event paradigm, we have access to MIDI note. And so here's frequency again. Right? We can say MIDI note 50. And here's MIDI note 91. And then we can also say note, 0 is middle C, so we'll go 2 octaves up. And even degree. Oops. Come on. Right. The only snag here is that this number is very specific to this specific sample. And so if you are going to be using lots of different samples, which are all pitched differently, then you might want to reconsider your plan of trying to make, maybe that isn't the best sample collection to work with musically, but you could also just make this another argument, and somehow when you load in your files, take note of the base frequency of each one and store that information somewhere, and then whenever you make a Pbind or play events, you would also provide base freak and then extract that information. We can't really do it dynamically through analysis. We probably can, but I think the way to do it is just in advance know the natural frequency of all of your samples and keep a record of it stored in an array somewhere and then grab it. But this is the basic idea, is to just take the frequency you want divided by the base frequency, and that becomes the appropriate ratio, which we can just plug right into playbuff. Make sense? No. I was just thinking about this the other day, and just if you're using samples but you want access to the pitch hierarchy and the event structure, so this is how I would do it. We're making great progress here. OK, sometimes we're working with a Pbind, and we want, I'm going to get this one, I think. We want to think about some parameter not in terms of number of events, but in time or beats. And we already did this with pfindur and the overall Pbind, but sometimes we want like one of these keys to behave like an envelope, where over X number of seconds or beats it will change. So let's go back to this version, and we'll do a 1/12 of a second. We'll fix this at 0.1, fix this at -20. So it sounds like this. And maybe I want the chromatic transposition value to drift from 0 up to 3 over 2 or 3 seconds or something like that. So pseg is the pattern I usually like to use for this. It's called seg, like the segments on an envelope, basically. So we provide patterns, a pattern that provides values that represent the levels of the points on this imagined envelope, and a pattern that provides the durations between those points, and then the curvatures of those segments, and then the number of times we want it to repeat. So this is the kind of vanilla way to do it. There's a better way, which I really like, which I'll show you in a second. But we want to go from 0 to 3 back to 0. We'll do, and I can never remember, and I forgot to check whether the duration pattern of pseg is seconds or beats. You can figure this out. I always forget to do it. It's one or the other. And then we'll just say lin for the, we're just going to make these linear. And then we'll say repeat this forever. Right. So this pattern is operating independently of the event stream. It's counting, time or seconds or beats or whatever. And so we have our levels 0 to 3 to 0, 2 seconds up, 2 seconds down, or beats up or beats down. And the way I like to do this is just a little bit slicker, is put an envelope in here. Using our trusty, familiar envelope language. And we can't do it as is. Maybe we can. Oh my god. And then we get stuck over here. OK. So what I do is as pseg. This is a convenience method which just takes the envelope, extracts the information, and builds the pseg for you. And I think this will stop, right, because that's the end of the envelope. But and so you might say, where's the repeats parameter? You can just call repeats on any pattern and set the repeats to be whatever you want. I think you can do this with any pattern, but this is basically going to take the envelope, turn it into a pseg, and then access the repeats parameter of that pseg and set it equal to infinity. So now it should go back down and then back up. Yeah, so that's thinking in terms of time instead of number of events. All right. Very good. Let's see. Do I still have my paste? I do. All right. I think this will be the last thing we cover today. We'll save real-time pattern control for next week, which is a very important topic when you want to actually start performing with patterns. And anyway. But let's focus on locking two parameters together. What I mean here is there are a lot of situations where you want the value of one pattern to depend on the value of another pattern. For example, if you're generating, let's fix MIDI note at like 40, and we'll say harmonic is going to be somewhere between 1 and, I don't know, 12. And we'll fix the decibels to be minus 20. And I'm going to say legato is 1.5, and the duration will be random. Something like this. This doesn't sound nearly as good as I thought it would. Let's make this really short, really quiet. We'll bring this down to 28, and we'll go all the way up to like the 20th harmonic. And what am I doing wrong here? If I take this away, let's just set. I'm just going to set the release parameter of the synth. That's more what I wanted. I think that's clipping. So an example here is maybe we want the high harmonics to be quieter, right? Because they pop out, we're more sensitive to the higher frequency range. And then the obvious question is, okay, we're randomly picking harmonic values, and I want 50 to produce low decibel values and 1 to produce high decibel, and smoothly interpolating between them. And with what we currently know, we don't really know how to do that, right? We obviously can't randomize decibels. That's not going to help. So one of the quickest ways is to use a pattern called p-key, which will look at the value of a previous key. And then we can just do basic numerical operations here. Like we'll say exp lin. So we have this exponential range from 1 to 50. And we want 1 to be, let's say, minus 15, and the highest value to be like minus 40. And while we are here, let's also talk about the pattern equivalent of post-ln. And we can't post-ln these. It'll just say, that's a px rand, and it's not going to actually tell us any of the values. Trace is the method which will actually wrap this pattern in a ptrace pattern, which is just responsible for also posting whatever it spits out. So you can sort of hear the low values are loud, the high values are quiet. Here's the, oh, you know why this sounds so crappy? It's because I'm not rounding. Yeah, I was like, what am I doing wrong? But no, this is what I wanted. I wanted a nice harmonic series, but X brand is floats. And so now we can see a high harmonic number is a relatively low decibel value, and a low harmonic number is closer to the minimum, right? So this is the quick way to do it. Another way to do it is our good friend pfunk, and this is a little bit more flexible than p-key, which doesn't always work in some cases. This is a little bit more robust. So with pfunk, we can declare an argument. And this argument represents the event that the event stream player is currently building. So we can say e.postln, and then we'll just return minus 30, just to give it a proper value here. And so we'll get rid of this trace. And what you'll see is the event get posted in the post window. Because pfunk is evaluating its function. We declare an argument to access the event that's currently being generated, and then it posts it. And here it is. And so this is just an event. And we know how to access stuff in an event. We say, I want e.harmonic dot explin from 1 to 50, minus 15 to minus 40. And so that also works. You can see that the harmonic is changing, and also the I think we need to do, like, why don't we just trace the whole Pbind? I'm not sure this is, or no, I'm tracing the pfunk. So you can see that the actual output of pfunk is the harmonic number mapped onto a suitable decibel range. So this is another way to do it. The pfunk, we get access to the event, and then we can access anything that is already inside the event. So you can even make one parameter be dependent on several parameters that are already in the event, and you can't do that with p-key. P-key is just one key, and then you use that. So 2 different ways to do it. These are all what I would consider sort of higher level, more intermediate pattern techniques, but they're all really useful. Some in musical situations that are a little bit more specific than others, but all good stuff to know, and hopefully good stuff to know as we start thinking about final projects and stuff like that. Question?
Yeah. Is E a default variable or?
No, you can call this whatever you want. Event, right? Just like how we do 5.do and then we declare n or something like that. Yeah, it's whatever you call it is going to be the event. So it doesn't have to be called E. Yeah. All right. As a reminder, the midterm is available. I'm giving you 48 hours to do it. So it'll be due 3 p.m. on Saturday. It's 6 questions. And based on what I've seen on the homework so far, I think you'll all be able to mostly breeze right through it. It's just kind of stuff you've seen before, making sure everyone's on the same page. And then the current homework that is assigned will be due on Thursday. All right? Thank you, and we'll see you next week.